And we have a great speaker today. My name, first of all, is Professor Steve Wheeler. I'm in landscape architecture. I'll be coordinating the LDA 190 speaking series this quarter on the theme of a sustainable campus. What's being done and what else can we do? Last week we heard from Skip Metzger, some background on the campus itself and the campus landscape. This week we hear from Sid England, who is Assistant Vice Chancellor for Environmental Stewardship. That title emerged recently in a reorganization that took place last year. Maybe you'll tell us about that a little bit. I'm going to pass around while Sid talks the sign up. Those of you who are enrolled in the course, please check off your name. And I think that's all I need to say as far as course introduction. If anybody has enrollment questions, see me later. With no further ado, Sid has a background in environmental planning and actually wildlife biology. He has worked for the Bureau of Land Management as a wildlife biologist, the Army Corps of Engineers, which not everybody would admit, as an environmental planner. He is an Aggie. He has a PhD in ecology from this university. He's also active with, I know, climate change planning in Yolo County and the Audubon Society and other local groups. So I think that's sufficient, so take it away, Sid.
Thank you, Steve. Thanks for the opportunity to talk today about sustainability initiatives here at UC Davis. I'll talk about our Office of Environmental Stewardship and Sustainability in a little bit. One of the things I'm going to do is I'm going to kind of steal a thunder from a lot of some of the speakers who are going to come later, as well as talking about some things that are really where our office takes the leadership. So one of the things about sustainability, the university has a mission statement. And the UC mission statement is teaching, research, and public service. And the sustainability goals that we've set for ourselves really fit into all three aspects of this. Teaching, teaching our students, researchers, people working on policy, new developments, new inventions, and then public service, getting that kind of sustainability messages out so other people can use it. As long as I've been here, coming from my background of land management and wildlife biology, I have personally, this is not the university's stewardship mission, this is my own personal addendum to it, is that stewardship and sustainability are also part of our mission. Bob Seeger, who's in the front row, I'll speak later this month, can attest to it. I've been saying that for 20 years now because we own 5,300 acres here. We have endangered species, we have a stream, we have a lot of natural resources, and coming from a public land background, managing those assets is pretty important. I think the university's commitment to sustainability, and when I say university, I mean the entire University of California, the whole UC system has been embodied and shown that it's strongly supported in a policy statement that came out in 2007 and then was edited and added to this last month. It's a 17 or 18-page document with lots of commitments and lots of things that we're supposed to be working on. So I'm going to give you just kind of the major headings in that policy document, all the things that we're trying to address, we're trying to work on. Some of them you're going to have some speakers later in your series that are going to address in real detail. I might hit a few highlights from those, but Bill Starr and Gary Dahl are going to talk about green buildings. Clean energy, as you might imagine, is a big one. We're talking about our carbon footprint. I'll get to some goals on that. Climate protection, again, trying to reduce our carbon footprint. Transportation, trying to have more efficient vehicles, cleaner vehicles, travel fewer miles. That's a big part of the UC policy on sustainability, and we'll have a speaker on that a little bit later as well. Operations, how do we make our operations here greener? What are things we ought to be doing to have less impact on the environment? Recycling and waste management, of course, are big ones, and all of these are integrated. They have aspects that may not be related directly to reducing our carbon footprint and our greenhouse gas emissions, but they all overlap in that area. Purchasing practices, trying to reduce the wastage when it comes from those. And last, food service practices. We're going to have a speaker again who will talk about those subjects in detail. So the ones up here in green are the ones that I'm going to spend a little bit of time talking about today. Mostly about clean energy and climate protection, a little bit about recycling and waste management and purchasing, which are kind of all related to each other in some regard. The last two there. And then I'm going to add one that's not on the UC sustainability policy, and that's habitat, wildlife, and land management. Just say a few words about that aspect of sustainability as well. All right, climate protection. So we set some pretty lofty goals. Our goal is to reduce our greenhouse gas emissions to 2000 levels by the year 2014. So that means in the next 5 years, we're supposed to reduce our carbon footprint to what it was 9 years ago. And by 2020, reduce it to what it was in 1990. 1990 happens to be the year I came to work for the university. And we've probably doubled our student population. We've probably added, I don't know, 2 million square feet or something like that of new building space. Our staff is probably not quite doubled. Never keeps up with the rest, but anyway. So we're basically supposed to zero out the growth that came along with the 90s and the 2000s and the baby boomers' children, the tidal wave 2, the echo boom as it's called, the children of the baby boomers. So by 2020, we're supposed to have found a way to zero out that carbon footprint. And then by 1990, we're to be 80% below the 1990, or by mid-century, we would be 80% below where we were in 1990. So when you start off, you can start off with some small goals, but you got to keep your ideas out there a little bit further and keep long-term ideas in mind. And I'll hopefully remember to mention one of those kinds of things a little bit later. Clean energy. We're supposed to reduce our per capita consumption 10% in the next 5 years. These next two goals up here are not for the Davis campus. These are UC system-wide goals. 10 megawatts of local renewable power by 2014. The last time I checked, the system was at about 6%. UC Davis does not contribute to that at all right now. They're really very small. There's one small photo array over by the student housing building. That's the only thing we have. Renewable power is this very specifically defined thing here, that if it's hydroelectric, is only can be put in this definition if it's small hydro. Large hydro, big dams cannot be counted towards this goal. And then 20% of grid power from renewable sources by 2010, again system-wide, and we're currently at about 15%. So those are some of our goals. And then waste reduction. This one, no landfill waste by 2020. So in 11 years, we're supposed to find ways that we don't send anything to a normal landfill. We may still be generating chemical waste, hazardous waste, biological waste, those sorts of things, but nothing that would go to a regular landfill. And there's a whole series of things or ways that are specified there that we might go about doing this. So big, lofty goals. How do we go about doing this? And then I just want to give you a little idea of the scale of the challenge for UC Davis. So we work in an office where we have the advantage of getting an overall view of everything that's going on. And we're really quite a big operation. This is a photograph of just what we call the central campus here. So here's Highway 113 that goes up to Maryland. Here's Interstate 180 to Sacramento and San Francisco here. So this is what we call the central campus. This is about 900 of our 5,300 acres that we have here in Davis, okay? Just to put that in perspective, this 900 acres, you could put the Berkeley campus once, UCLA twice, and have nearly 100 acres left over. Okay? Just to give you an idea of the size of this place. So it brings with it a lot of challenges. Over 1,000 buildings, and that's just in Davis. Lots of students. The employee number here includes all UC employees, whether they're on the Davis campus or they're in Sacramento or someplace else, and that's temporary and part-time added together. And then we have outlying facilities. So when we're thinking about how we're going to be sustainable, we don't just think about our piece of land or our campus here in Davis, we think about everything. So this is the medical campus over in Sacramento. It's about 130 acres. They've got a couple million square feet of their own facilities over there, and they've got 15,000 employees. When we're looking at our carbon footprint, we have to include them. It's not like we get to forget about them. And they're very, as you can imagine, hospitals, clinics, research laboratories, they're very energy intensive. And then we have a number of significant outlying facilities. I guess I have that one up there twice, don't I? The Degg Marine Laboratory shown here. Tulare Veterinary Medicine Center, Tahoe Environmental Research Center. That's just a short list of the things that we have scattered up and down the length of the state that are part of what UC Davis administers. So it's a really big challenge. So where are we? What's our carbon footprint look like? One of the things in our office, environmental stewardship and sustainability, is we're putting together the campus's current, projected future, and historical carbon footprint to help us identify what our goals are. So this is metric tons of CO2 equivalent, and I don't know, should I explain what that means? Or? Okay, so there's 6 Kyoto greenhouse gases, and carbon dioxide, of course, is the main one. But the other 5 are also significant, and they have a greater effect on the environment than carbon dioxide does. So there's multipliers. So methane is 28, Alan, is that the right number? Thanks. So every molecule of methane that you put in the air has 28 times the effect of 1 molecule of carbon dioxide. So when you're looking at these other 5 gases, you have to turn them into what we call CO2 equivalents by multiplying them so that they are on the same scale as CO2. So the Davis campus is about 250,000 metric tons of CO2 equivalent per year. That was our estimate in 2000 for the calendar year 2007. We're working on the 2008 numbers right now. We don't quite have them together. We're within a week or so of having them, but this was the 2007 estimate. You can see that places like Berkeley, Irvine, San Francisco, San Diego are quite a bit lower than we are. Los Angeles, a little bit higher. We're pretty comparable to some other large campuses in other parts of the country, Arizona State, Cornell, Maryland. So we're high on the high end for the UC scale, but we're within the range for a whole variety of campuses. And I have to admit that carbon footprint reporting is not as exact a science as you might hope. But we take a pretty conservative look here, and conservative in the sense of trying to be very inclusionary and be as accurate as we can. And so sometimes when you're comparing to, I won't name names, but when you're comparing to other campuses, you might not be comparing apples to apples. There may be some things that are in ours that aren't in some of the other ones, but we're trying to be as inclusive as we can as we go forward. Is that diplomatic enough? All right. So if we look at all of our UC Davis sites and we say, where's our carbon footprint being generated? About 70% of it is here on the UC Davis campus. So it's about 175,000 metric tons. 27% at the medical campus in Sacramento. About 6,600 tons at outlying facilities, about 3%. And our fleet, you know, it's not a geographic thing. It's calculated a little bit differently when we do our submittals to the state. The fleet is broken out. Is about 1% of our total emissions. So anyway, that's where it happens geographically. So obviously, the Davis campus is the largest part of that. When we look at the Davis campus and break it down between different sources to see where it's coming from, purchased electricity is about 51%. So about half of our carbon footprint comes from our use of electricity. That number really varies a lot from year to year because we buy our power. Most of the rest of everybody in the state buys their power from either Sempra down extreme Southern California Edison in the LA area, Bakersfield, or PG&E you get further north. We don't buy from those. We buy from a federal agency called the Western Area Power Administration. And their supply of power really is dependent on whether it's been a wet year or not. If it's been a wet year, they have a lot of hydro in their system. If it's not, then they go out and they buy it from the market. They tend to buy a lot of it from outside California. So it can be power that's fairly, quite a bit of it could come from fossil fuels. So how much this is really varies from year to year, depending on how much rainfall there's been. It can vary from as low as 18% to as high as 30 or 40%. So I hope today to give you what the timing of this lecture is just a couple weeks earlier than it would have been nice, but I hope to give you what our 2000 or 1990 targets are, and I'd be happy to come back with those in a few weeks. But because of this variation in rainfall, we're going to have to do some smoothing to kind of get a curve where we can pick a 1990 and a 2000 number that's not just the vagaries of that particular year, but something that's more of a trend. So we're working on trying to figure out how to do that right now. The Sacramento campus, the medical campus, is a whole different story. 92% is from stationary combustion. And the reason for this is a few years ago, they decided to build a cogen plant, which is very efficient, really reduces emissions to the atmosphere, but it burns natural gas. There's not a whole lot of alternatives to that. You can't go out and buy, I mean, maybe in the future you might be able to buy biogas and offset it and do some things like that, but right now those kind of options aren't available. So for the next 30 years probably, they're committed to that as their primary source of power. They even actually now sell power to SMUD. They generate more than necessary to help SMUD with their peaking loads over there. So one of the things that this does is, when we're looking here at our stationary combustion on campus, which is about 40%, we have a chilled water, or a central heating and cooling plant that does chilled water and steam. And we need to do upgrades to the system, and so one of the things looking way out to mid-century, one of the things we want to think about now is, do we replace the existing boilers with gas boilers, or do we find ways that we could convert to electric boilers? What does that mean cost-wise? What does that mean maintenance-wise? If you go to electric, then maybe you have other options. You can look for greener electrical power sources in the future, but as long as you're committed to natural gas, you're kind of stuck. What are some of our special challenges? We get involved in everything that has to do with greenhouse gas emissions, more so than any other campus. If you're at UCLA and you get on the local public transit, the footprint of that public transit is the public transit's issue, not UCLA's issue. You get on our Unitrans, we own it, we run it, it's our footprint. If you're at Los Angeles and you turn on the faucet, you're getting water from the Metropolitan Water District. The energy costs of that water are an issue that the Metropolitan Water District has to deal with. Not so here. We have our own water system. We have all of our own utilities. So all the energy costs, that's one of the reasons why our bar is a little bit higher than others. Okay. We're very science intensive. I don't know if we're the most science intensive of all the campuses. I can't remember. I think that's right. Labs are big energy consumers. It's another issue we have to deal with. And there's 4 other campuses that have health sciences. But we're the only one that also has a veterinary school, which is basically another health sciences school, and all of the intense uses that go along with it. Our power supply is unique, I mentioned that already. And we have an inland climate. If you think back to that graph of the different UC schools, Santa Barbara, San Diego, Irvine, Santa Cruz, or whichever ones they were, all very low. They have a very mild climate. They don't have to heat as much in the summertime. They don't have to cool as much in the summertime and heat as much in the winter. So all these things are challenges that we have to deal with. So about a year ago, we created our office, the Office of Environmental Stewardship and Sustainability. Campus has been working on sustainability issues and decided there needed to be some people who woke up every day trying to meet the goals that have been set out for us as part of their job to see how we move us forward. So what we really do is we coordinate things across campus. We try to link the faculty and the staff to see if we can take research and bring it into what we're doing. We measure and track the various metrics that we need to do to track our carbon footprint, our waste diversions, that sort of thing. We're right now preparing what I'm calling version 1.0 of our climate action plan. It should be done by the end of the month. We're going to use that then as a kickoff point for a larger campus involvement to figure out what should version 2.0 be, which I think is going to be kind of fun. We're a little behind the other campuses, but they started off without anything. I think we're going to be able to start off with a document where people can really roll up their sleeves and get to work on some meat with some real numbers to look at. We're also going to be the office that works on leading behavioral change, getting people to turn off lights, make different choices about how they do things. There's lots of people on campus that are engineers and designers and things like that that can work on infrastructure issues, but we're the ones that need to work on some of those things about getting people to recycle, to save electricity, that sort of stuff. One of the other things too is that there's been a big reorganization that's gone on. Office of Administration and Office of Resource Management and Planning have merged just as of a couple of weeks ago. And a lot of changes in who reports to whom and all of that. But our group, Environmental Stewardship and Sustainability, continues to be a direct report to the Vice Chancellor. And he's done that specifically because he wants somebody to be able to be an advocate for these environmental and sustainability issues without a filter between him and those issues, or somebody who has to worry about running day-to-day on the ground kinds of issues. So that the policy issues and choices can be brought forward. You know, what the decision will be will depend on a myriad of factors, but we'll be able to have that direct reporting relationship, which I think is very important. So besides me in our office, we have Alan Doyle. Alan's in the back here. You want to raise your hand? Okay, he's our sustainability manager, and Alan comes from a background as a lab manager for 20 years at UC Santa Barbara. Great addition to our team because he can go in these big energy consumptive labs, work with the people, know what it means to be working in a lab, know what the kinds of issues are, and be able to sort of speak the language and be able to work with them on ways to save energy. Camille Kirk, who's in the middle here, is already heading up putting the climate action plan together, the inventory work, and the building stewardship program. Really focusing on some of the behavioral change type issues. She would have been here today, but I think the swine flu has hit their household. So she's not here today. So. And then as of last week, as part of the organization, the R4 recycling program has moved out of the grounds department and is now linked up with us. Which again, I think makes a lot of sense because we have goals for waste diversion. And again, now this program is in an office where we can be an advocate and raise issues. And it's not through one of the day-to-day operations parts of the campus. So I think that'll be good. And students. Right now we have in our office, Devin Soares, an undergraduate, or Dan Savasier is a graduate student who's helping us put together the final parts of the inventory and the projections of what our 2000 and 1990 goals are. Gloria May Guzman works for Alan, is helping with the Green Laboratory program, and then the picture here is of the R4 team that works on recycling on the campus. So, how do we reduce our carbon footprint? I think there's 5 big broad categories. One is when you build new things, make them as efficient as possible. That doesn't actually reduce, but it keeps it from growing as fast as it might otherwise. Second is improve energy efficiency of the existing facilities. So take what you have and make them better so they use less. Third is try to have your users make choices that reduce the demand that they put on the systems. Fourth is we need to find greener energy. So build smart, use less, and then you're not going to use zero power. You're not going to use nothing. Find ways to have to green up your energy consumption. The last one, I won't really talk about this one, is to see if there would be a possibility for sequestration. Is there some way we could actually take carbon out of the atmosphere? I think this is a question that you couldn't even ask at any of the other campuses, maybe Merced. But we have a pretty good sized land base here, and I don't know. Maybe there's something we could do. If we put our heads together, maybe we could grow a crop that went into a biodigester, and I don't know. Those are some of the kinds of things we need to think about. So for new buildings, again, Bill and Gary will talk to you more about details of some of the great buildings they built, but I want to give you an overview of how it fits into reducing our footprint from new facilities. Have you talked about LEED or anything in this class?
No.
Okay. There's an organization called the U.S. Green Building Council that has a program called Leadership in Energy and Environmental Design. It's a point system. When you build a new building, depending on how you treat energy, waste, a whole variety of things associated with the building, you get points. It's related to land use, habitat, a lot of things. Total up the number of points at the end, and your building can be rated as either certified, which is the lowest, silver, gold, or platinum. So to make sure we're moving down that direction, the UC system is using that rating protocol as a way to determine whether or not we're building buildings that are environmentally sound. Policy for the UC system is that everything should be silver, but we should strive for gold. So that's what we're shooting for. There's a few exceptions for small buildings or buildings in remote places and things like that, but overall that's our goal. There's a thing called the Title 24 of the California Energy Code. It's probably the strictest building code in the United States about energy efficiency in buildings. The UC system has a goal that we should exceed Title 24 by 20% and strive to exceed it by 30%. We were the first campus that ever set a goal, and we started off with trying to beat it by 10. And then when the UC system said our goal is 10, we raised ours to 20. When the UC system said our goal is 20, we raised our minimum to 25. So we're trying on this campus to do better than the system and beat those energy conservation goals by 25%. So just to give you an idea of where we are in these buildings, this list of buildings are buildings that are either have been certified or are the equivalent or will shortly be certified as in the silver category here on campus. This is being a picture of Geet Hall. These are at the next level. These are the same as are at the gold level. Some of you probably had classes and things in them. And these are two that are at the very highest level. The Tahoe Environmental Research Center is actually fully certified. It's up at Lake Tahoe. If you ever get a chance to go up there, you can tour the building. It's on the Sierra Nevada College campus in Incline Village. It's really an amazing building. Rainwater capture, micro generation within the building. The actual local power grid is the backup to the building. I'm trying to think. They actually brought a mill in on site, milled trees on site to create some of the wood that was used in the building. It's really quite innovative. All of this picture, I have to tell a little story. All of the rooms have motion sensors in them. So if there's nobody in there, the lights go out. So they wanted a picture at dusk with the sunset in the background, and they wanted all the lights on. Well, how the heck do you do that? You get a whole lot of students and a bunch of radios, and you say, all right, everybody knew where they had to go, and you say, go. And as soon as all the lights come on, you tell everybody to duck. So that's how this photo was taken. Anyway, this was the third laboratory building in the United States to receive platinum level. Laboratories are really hard to qualify. There's a whole separate program that Alan is very involved in called Labs 21, which is trying to set standards about how you take into account the uniqueness of a laboratory building and make it very efficient. So there's a whole other set of standards. Another way to reduce growth from West Village, or from new facilities, is I want to say a couple things about West Village. Bob, I know, will say more in his talk in a couple of weeks. Campus has a project to build a neighborhood here. Eventually have about 5,000 people living there, and it'll be occupied by about 3,000 students and faculty, and then also faculty and staff. So it's a mixed-use neighborhood with multifamily dwellings, single-family dwellings that will be owned by the faculty and staff, an education center, and a village square. But what we've done is we have set out the goal of trying to build a community on 200 acres with that many people and have zero net energy from the grid. That's what we're working towards. So that's not reducing our consumption, but it's keeping it from going up, which is, if you let it go up, you're going to have to then do other things to bring it down. So first we said, what can we do to reduce energy consumption? And we started looking at energy efficiency measures. We have a whole bunch of them up there that have been evaluated. We've worked with our Energy Efficiency Center on campus, with the California Light Technology Center on campus, with the Western Cooling Efficiency Center on campus. We've got a technology contributors forum where we evaluated which ones we put in there to try to get the energy consumption down so that then we could see if it'd be possible to produce enough renewables on site to balance the load on an annual basis. On an instantaneous basis, there may be sometimes electricity flowing one way or the other from the grid, but on an annual basis, it would approximately zero out. So what we're talking about now, the big components of it are lots of energy efficiency measure, what we're calling deep energy efficiency. We're seeing, what we're thinking we can do is that those business as usual meeting just Title 24 standards, this neighborhood would consume 22 million kilowatt hours of electricity per year. We think with energy efficiency we can get that down to 9. Okay, and just to put this in perspective, electrical consumption of the whole Davis campus here in Davis is about 280 million kilowatt hours a year. So that's a pretty significant piece of that number that we're going to keep it from going up, we hope. And then solar thermal on the homes to preheat water, and then we can use electrical heating on site to get it up to the temperatures we need in the home, and that allows us to eliminate the natural gas system from the single-family dwellings. Then we're looking at distributed solar photovoltaics. It would be not on individual homes, but in common spaces. Easier to manage, easier to install, a lot less costly. We're looking at up to 5 megawatts of installation. And then a community energy park where we put in a biodigester where we would take waste from the neighborhood and from the campus, digest it to produce methane and hydrogen, which would then go to a fuel cell, which would produce a base electrical production and a battery that could store it, an advanced storage battery, that could then put it into the system as it's needed over the course of the day. And then all of this would be linked with a smart grid. And the smart grid, this whole thing we hope will be a living laboratory where we can research new technologies and things. So for example, one of the ideas would be that you could come in the future, park your plug-in hybrid electric vehicle or your electric vehicle under a covered parking space, so you get the shade benefit, but it's got solar on top. You could plug your car in right at the base, wave a card in front of a sensor, it would know who you are, and it could put that electrical consumption on the proper bill. So the smart grid would talk to itself and do all kinds of things. That's where we're hoping to go. All right. How do we improve existing energy efficiency? We have a program called the Strategic Energy Partnership with PG&E. It's a 2009 to 2011. We've just found out we're going to get to add another year. We're going to spend over these 3 years about $31 million in energy efficiency projects on buildings here on the campus. Sacramento campus has its own program. About $12 million will come from PG&E towards this program. We'll spend about $19 million, and that'll be funded by savings from our energy purchases. So we're going to be working on there's about 162 projects at about 80 to 90 buildings. Monitoring-based commissioning is where we go into the building, and just like a car gets out of tune, a building does too. So monitoring-based commissioning is where we go into a building, we tune up the heating and air conditioning system, we look at a whole variety of electrical systems and tune them up so that they're operating at best efficiency. We're looking at lighting retrofits, and then also improvements to the heating, ventilation, and air conditioning systems. So the potential savings from this program, we think once it's all in place, we'll save about $5.5 million a year from our purchased utilities budget and about 38 million kilowatt hours per year, again compared to our campus right now demand of about 228. There should be a million in there. It's not 228 kilowatt hours per year, it's 228 million kilowatt hours per year, which is about 16%, so it's a pretty significant program. The other thing that's going to happen in addition is that we've been building a lot of new stuff. As time goes on, we're going to be building money that we do have for capital projects, which is getting to be less and less with budget issues. But there's going to be a lot more renovation projects. And those renovation projects will be opportunities to go into older buildings and get them up, with more efficient systems as well. So that's another way we're going to improve our energy efficiency. There's another LEED program. Remember I talked about the LEED for silver, gold, and platinum. That was for new construction. There's a whole other program for what's called Existing Building Operations and Maintenance. One of my favorite acronyms, EBOM, EBOM. The one we're starting with is Shields Library. And they have a whole rating system where you go in there and you go through the building, and again, it's a point system, and it's not just the building. And it's not just electricity, it's water consumption. What kind of fixtures do you have in there? It's sitting down with people and training them about recycling. It's sitting down with people and talking to them about transportation options and things like that. So it's a broad program. And we're starting off with Shields Library, and then we'll grow from there, hopefully. We have already in place a refrigerator freezer buyback program. Campus right now, if you're in a lab, maybe other settings too, I guess it's in general. If you have an old freezer before 1994, it's not energy efficient. And the campus is willing to match up to $400 for the purchase of an Energy Star refrigerator. plus we'll pay the cost of disposing of the old refrigerator appropriately. So if any of you are, you can go look at the nameplate inside the refrigerator. Somewhere in there there'll be a little plate that'll tell you the model and all that stuff, and it'll have the year that was produced. If it's before 1994, that program is available.
There's only fridges on campus, right?
What's that?
Not your private fridges.
Not in your home, no. And now, also we have a large parking lighting retrofit program. Cliff probably will talk about it when he comes. His topic's about transportation, but I'll be surprised if he doesn't. But it's a great program linked with our Lighting Technology Center. They actually developed some fixtures that are now going to go system-wide. But if you ever go to the north parking structure or the south parking structure, when it's dark, it used to be those lights were on basically all the time, or they came on at a set time regardless of the light levels, and they ran full blast until the systems turned them off if they did at all. The ones they have now are LED, so they're more efficient. They have a 50% lighting level and 100% lighting level. And they have a motion sensor. So if there's no motion, they go down to 50%. If there's motion, they come up for like 15 minutes or something like that at 100%. What I understand from Cliff with Transportation Parking Services is that he looks like his electrical bills are going to drop by between 50 and 60%. And he's going to be able to pay back those investments in like 6 years. We were concerned when this started that the security people, the police department would be worried about having lower lighting levels. Turns out they love it. 50% lighting is more than adequate to see what's going on. And if there's anybody in the structure or in the parking lot moving around, they know where they are because the lights are bright. Okay? It works for everybody. And we're also working on we're working again with Michael Smitovich at the Light Technology Center on maybe coming out shortly, hopefully with a large long-term campus goal for trying to, indoors as well as outdoors, reduce the energy consumption from our lighting. Reducing user demand, this is kind of, again, coming back to our group. The Building Stewardship Program, which Camille is going to be heading up. We're looking at the possibility, right now every department on campus has a safety coordinator. We're thinking maybe over the long term, we should look at the possibility of a sustainability coordinator. That's sort of a parallel idea. The whole sustainability thing is not going to work if it's top-down. You've got to have top-down support, but you need it to start from the bottom up. So we're looking at this as a possible thing to work towards over time. Alan working on the laboratory stewardship program. We're thinking about maybe the possibility that we might create a program over time where your lab could be certified as a green lab by having a set of things that you accomplish within the laboratory, or maybe your department, or maybe your building. Building stewardship, I mentioned sustainability coordinators. We're looking to start working with departments or maybe whole buildings, maybe as part of the LEED EBOM program or the monitoring-based commissioning program, have developed departmental building sustainability plans. We want to provide campus-wide resources on where are the best things to do, and there's other things here that will be included in those kinds. And the last thing I want to mention here, this is a student. Camille worked with a Davis Honors Challenge group, and we took our office on the 3rd floor, our office plus the University Communications, and we went for several months and we said, if we're going to do these things in other departments, we need to walk the talk. So let's see, how do you do things, how do you educate people, and how do you make them stick? And so we learned a lot just by working with our own people in our own office about myths about whether you should turn your computer off at night, whether it's bad on the hard drive or not bad on the hard drive, or when does your IT guy keep your computer on all night because it's convenient for him to do backups. Well, maybe there's another way to do it. So we learned a lot. We used ourselves as a kind of test bed. Alan's working on the laboratory stewardship program, and it's sort of like fume hoods, fume hoods, fume hoods. Alan, energy consumption of a fume hood running full blast is equivalent, depending on the kind of fume hood, equal to one fume hood between 1 and 3 typical homes. Right? Is that the number? Those are the numbers. That range, right? Yeah?
Yeah.
Okay. All right. So, Alan, this is Gloria Guzman here, a student working with Alan, and they're doing inventories of buildings where the room may not even be a lab anymore, but it was a lab and has a fume hood sitting in the corner running full blast. And it's probably been on full blast for years. Okay? If any of you know those settings, those places, or aware of it, tell Alan. Alan, you're right there. Okay? Waving his hand, all right? Because we want to know about those. depending on how the air circulation in the building works or whatever, we may be able to shut it down. There's some conditions where that might not work, depending on how the whole building is balanced for its air conditioning. SASH management is another thing. More modern laboratory buildings. Old lab buildings, the fume hood runs and it just runs. New ones, if the sash, the sliding up, the window slides up and down, is halfway down, the motor powers down because it doesn't have to move as much air through that front. The more you shut it, the lower it gets. So you can save a lot of energy that way, but most people don't know how to run them. They're never instructed. So Alan developed this little sticker. He's got it in about 300 labs now. That shows you that the red zone is expensive and not safe. And the further down you get, the greener you are, both in terms of energy consumption and safety. So he's out getting these things out in the departments and trying to help people use these in the most energy efficient way possible. He's also got a big program working on cold storage. We have, how many minus 80 freezers on campus? Do you?
848.
848. He estimates that he consume $1 million worth of electricity a year. Okay? Most of them are used to store specimens. Most of them are used to store DNA and protein specimens. There's a whole new technology now that's developing it's called dry storage. You can use certain chemicals and certain methods. You can basically sort of freeze dry them, for lack of a better term, and you don't even need a freezer. So he's working with the people over in the GDOLA Biomedical Sciences facility, people in the College of Biological Sciences, and trying to get very conservative scientists who are worried about not doing things differently than they used to start to adopt these programs. And we're even seeing if we can use some of the PG&E Strategic Energy Partnership money to create incentives for people to convert, and then we're going to steal their minus 80 freezer and get it out of there. Or if somebody else needs one, truly needs one, that's one less you have to buy, and you can save some money that way. So he's working on those. He's also working on ventilation. Sometimes you can, in a lab, you can put like the thing that generates the most heat in the whole lab right next to the thermostat. And other kinds of things, set points. How much temperature range can you have in the laboratory? So he's really working hard on these programs. But then he's also looking at non-energy related things too. It's not as high on the docket right now, but there's still things that we're working on as well. And then how do we reduce our carbon energy, our footprint from our carbon? First thing is West Village. We're trying to bring that out of zero net energy. Second thing is we've had a campus solar work group. Phase one is we're looking at about putting 900 kilowatts of photovoltaics on the campus. We're actually working on a request for proposals to go out very shortly that would have us put photovoltaics on this list of buildings that you see here on this list. So that's already pretty far down the track. One of the problems we have with photovoltaics, it sounds like a great idea, but we buy our power, as I mentioned, from the Western Power Administration, and we get our power for about 9 cents a kilowatt hour, which is really cheap. We're not going to put in photovoltaics because it's less expensive. We're going to put in photovoltaics because it's the right thing to do. It's going to cost a little more money, but when we do it, that's going to be the reason why it's done. And then we've got a phase two that we've just started on, thinking about whether we should do some bigger installations on campus or look at other buildings and kind of learn something from this smaller going forward. So when I showed you that we didn't contribute to the renewable resources system-wide, that'll start to change as time goes on. Waste reduction, just a couple of things I wanted to mention. We achieved a 69% diversion in 2008. So that's really high. It's maybe the highest in the whole UC system. I have to put a big caveat on that, though. That does not include the Sacramento campus. So the Davis campus is doing quite well, but when we add our other facilities in, it's going to take a big dip. And then West Village, though, is going to be real interesting because we're putting in the biodigester. It's going to take various organics from West Village in the biodigester. But then we're also looking at taking green waste, food waste, and animal waste from the campus and using them in the biodigester. So that can help us in a bunch of ways. It could generate electricity. It could help us with our waste diversion goals. And also some of these, like the animal waste, could actually help us with some water quality issues we have associated right now with disposing of animal waste. And then the last thing I wanted to mention was habitat management. Again, this is not part of the UC policy, but I think it's important when we're talking about sustainability. The Poudre Creek Riparian Reserve and the Russell Ranch Mitigation Area, all told is about 550 acres. It's about 5.5 miles of stream frontage down along Poudre Creek. We have a reserve manager and a reserve steward who manage it. They're in Bob's group in, what's the name of your group now, Bob?
Campus Planning and Community Resources.
They were just reorganized, and now they're mashed up in that group, which I think is great, with the Arboretum and the grounds. And I'll show you some things that are coming up. We have 2 endangered species there, the Valley Elderberry Longhorn beetle on the left and Swainson's hawk on the right. So thinking about these from a long-term perspective is another important aspect of what we're doing. By setting up the reserve, I think we're doing a great job. And I'll mention the Russell Ranch Mitigation Area. As part of our mitigation for development on campus, we've taken 380 acres that was in agriculture and looked like this a few years ago. It was 10,000 of these posts, wires, ornamental trees as windbreaks, and we've gone in there, and this is what it looks like today. This is the beginnings of restored natural grassland. The orchard there that we took out had been abandoned and for about 10 years because it wasn't viable economically, and we had oaks that had grown up volunteer, and when we saved them, we worked around them. So we actually have a 5-year-old restoration site that has 15 to 20-year-old trees, which is like really cool. A lot of this work, not at the Russell Ranch, that's large scale, but on the reserve, on the main campus, a lot of restoration work, oaks, grassland plantings, a lot of volunteer work. Andrew and JP have done a great job there. And now what's started to happen, will happen more, is they're taking their talents and things and their experience, and they're helping us design and implement natural landscapes on other parts of the campus outside the reserve. So this picture in the lower right is a stormwater detention pond out by the Primate Center out at Road 98 and Russell. And it's grassland, wetland, and you can see some of the trees that were planted here. And working with Bob now and his new group, they're going to be looking for more opportunities to do that on campus as well. So right at the end, I think I'm right here at the right time. What is sustainability? We've been talking about it. It's a word that I think has started to have so many definitions that you don't really know what it means anymore, sort of like green. This is the Brundtland Commission definition in the 1970s, I think it was. The United Nations put together a commission, and this is the definition they came out with. And that's more or less the one that the University of California uses. There's a few others, though, that I've heard that go into different meetings and things that I kind of like. So there's an economist. There's a parent. This is okay. There's a golfer. And if you have any others, I'd love to know so I could add them to the list. So, will we achieve our goals? I think by drawing on all of our expertise and trying to work together. I think that we have to combine it with society kind of changing its goals and putting its emphasis in other places. And with all that, I think the answer is yes. So, thank you, and I'd be happy to answer.
Okay, I'd just like to point out one thing about Sid's talk, and I think that you'll notice about our other talks in this series also, is just how interdisciplinary this work is. Some of it's design, some of it's planning or environmental planning, some of it's policy, and some of it may be other things, engineering, technology, and that's what sustainability is about. It's about coordinating these things together. We have time for maybe 1 or 2 quick questions. Would anybody like to lead off?
Okay, thanks. No, I'm serious. If there's any questions, or come on.
Okay, well, Sid will be available. Thank you very much, Sid, for joining us.